Imagine opening a history book and discovering entire civilizations that supposedly existed before history itself began. That is essentially what astronomers experienced when the James Webb Space Telescope started sending back its first observations. For decades, cosmology seemed relatively secure. The broad outline of the universe's history appeared well understood. The universe began approximately 13.8 billion years ago. Matter emerged. Stars formed. Galaxies slowly assembled. Complex structures developed over immense stretches of time. The story was not complete, but scientists believed they understood the sequence. Then James Webb arrived. And suddenly the timeline became far less certain. Unlike previous observatories, Webb was specifically designed to detect ancient infrared light. Because the universe expands, light from distant objects becomes stretched, shifting toward longer wavelengths. The farther an object is, the older the light we receive. When Webb looks deep into space, it is literally looking back in time. Back beyond familiar galaxies. Beyond the birth of the Milky Way. Toward the first moments when structure began emerging from cosmic darkness. Scientists expected to find primitive galaxies. Small collections of stars. Messy, irregular objects still struggling to form. Instead, Webb discovered something astonishing. Some of the earliest galaxies appeared unexpectedly large. Unexpectedly bright. Unexpectedly mature. Many contained far more stars than existing models predicted. Some seemed to possess organized structures that should have required much longer to develop. It was as though archaeologists digging into ancient soil suddenly uncovered modern skyscrapers. The discovery immediately triggered debate. Were the measurements wrong? Had astronomers miscalculated the distances? Could these galaxies actually be much closer than they appeared? Teams around the world examined the data repeatedly. Yet observation after observation pointed toward the same conclusion. The galaxies were real. And they existed surprisingly early in cosmic history. Some appeared less than 500 million years after the Big Bang. To understand why this matters, imagine compressing the entire history of the universe into a single year. These galaxies would appear within the first few days of January. Yet some already looked as if they had undergone millions of years of development. The implications were profound. Perhaps stars formed much faster than expected. Perhaps galaxies assembled more efficiently. Or perhaps some aspect of our understanding of the early universe remains incomplete. The surprises continued. Webb began detecting enormous populations of stars in places where astronomers expected only small stellar nurseries. Regions that should have been cosmic infants appeared strangely mature. Every new observation added pressure to existing theories. Yet science advances precisely through moments like these. Not when predictions succeed, but when reality refuses to cooperate. The deeper Webb looked, the more the early universe resembled an environment of rapid growth and extraordinary activity. A universe that may have evolved faster than anyone imagined. And if galaxies formed sooner than expected, another mystery immediately followed. What powered such rapid evolution? Because hidden inside these ancient structures were clues suggesting that something even more extreme was taking place. Something involving the most powerful objects known to exist. Black holes. And their existence may prove even harder to explain than the galaxies themselves. Among all the discoveries made by the James Webb Space Telescope, few are as unsettling as what it has revealed about black holes. Black holes are already among the strangest objects in the universe. Their gravity is so powerful that not even light can escape once it crosses a certain boundary. Yet despite their reputation, scientists believed they understood how the largest black holes formed. The process seems straightforward. A massive star dies. A black hole forms. Over millions or billions of years, it grows by consuming gas, dust, and occasionally other stars. Slowly, steadily, its mass increases. That explanation worked well, until Webb looked into the distant past. Near the dawn of cosmic history, astronomers began finding evidence for black holes that appeared far too massive. Far too early. Some contained millions, even billions, of times the mass of our Sun. The problem was time. There simply should not have been enough of it. According to conventional models, these objects should have required much longer to grow. Yet there they were. Already enormous when the universe itself was still very young. Scientists immediately began searching for explanations. Perhaps the first stars were far larger than expected. Perhaps early black holes consumed matter at extraordinary rates. Or perhaps some formed directly from gigantic clouds of collapsing gas, bypassing the normal stellar stage entirely. Each possibility remains under investigation. None fully explains every observation. And the mysteries extend beyond black holes. Webb has also examined the chemical fingerprints hidden inside ancient galaxies. Those fingerprints reveal the presence of elements such as carbon, oxygen, and nitrogen. These elements are crucial because they are not produced during the Big Bang. They are manufactured inside stars. For them to appear in abundance, multiple generations of stars must have already lived and died. Yet Webb sees these chemical signatures astonishingly early. This means stellar evolution may have progressed much faster than expected. The universe appears to have rushed toward complexity. As if cosmic history unfolded at accelerated speed. Then there is another discovery. Complex organic molecules. Across distant clouds of gas and dust, Webb has identified carbon-based compounds drifting through space. These are not living organisms. But they are among the chemical ingredients associated with life. What makes the finding remarkable is their age. Their light began traveling toward Earth billions of years ago. Long before our planet existed. Long before the solar system formed. The ingredients of biology were already present. Waiting. Scattered throughout the young cosmos. This realization changes perspective. Life may not require rare circumstances. The chemistry that supports it could be woven throughout the universe itself. Perhaps the most important lesson from Webb is not any single discovery. It is the growing realization that the universe is more complicated than our models predicted. Galaxies formed faster. Black holes grew sooner. Chemistry became complex earlier. Structure emerged where chaos was expected. The deeper we investigate cosmic history, the more surprises appear. And that is exactly why the James Webb Space Telescope represents one of humanity's greatest scientific achievements. It is not confirming what we already know. It is exposing what we do not know. Every image. Every spectrum. Every ancient photon that reaches its mirrors carries information from a time before Earth existed. Messages sent across billions of years. Messages that reveal a universe still holding secrets beyond our imagination. The greatest discovery Webb may ever make is not a particular galaxy, star, or black hole. It may be the realization that the true story of the cosmos is far stranger than we ever believed. And we have only just begun reading the first pages.